Hi everyone, this is Mr. with one more example from section 6.3. So section 6.3 in our book is all about confidence intervals for a population proportion. So we're on everything else we've done so far, we've been wanting to estimate a population proportion. However, this part of the section is actually slightly different. It's still dealing with proportions, but we're specifically trying to identify what sample size would I need in order to be able to estimate the parameter, this population proportion, within a certain margin of error. So maybe I want to make sure that I've got the right number within just 1% of in either direction. Then I would need to, I can calculate what sample size I need. So we're going to go to the same start off going to the same place. So we're going to go to stat and then proportion stats and one sample. Like I said, we're not going to be doing two sample, so we don't have to worry about anything other than one sample. But instead of selecting with summary, that's what we use to get our confidence interval, we're going to choose the width / sample size. So those are the only two options that we'll be using. So width / sample size. So if you're looking for the sample size, choose the one that's got sample size in the name. We're going to end up, we'll have a window that looks kind of like this. And sorry, unfortunately with my document camera and the setup I have right now, I cannot show both my screen and my document camera, so I can't pull StatCrunch up, but I've printed off this lovely image. And so when you get into StatCrunch, you'll have the confidence level, which I believe is 0.95 as the default. Your target proportion, the default there is 0.5. And then you'll have some numbers over here. We're going to change those, so that part doesn't matter. We're probably going to change these numbers in the required parameters as well. But I don't know, this is some big long decimal if I'm remembering correctly. And I think the sample size might be 4. So let's see what we'll need once we get to our actual example with numbers here, example 5. But we're going to put our confidence level in. Of course, that's going to be as a decimal. So maybe 0.90, 0.95, 0.98, 0.99. If there's something different, then, etc. And so that's our first part. Then, if a previous estimate of p hat is given, we want to put that into the box for target proportion. That's right, that was that second box under the required parameters. So if we don't know anything, however, we're going to use 0.5. 0.5 will give us the largest possible sample size. So if we have a p hat, that helps us narrow down. We have some reason to believe that it might be, larger or smaller than a half, and so we don't have to have quite as many in our sample. But if we don't know, then we use 0.5. Then we want to enter the width, and that is key. We're not entering the margin of error. We're entering the width of the confidence interval. So remember, when we were talking about our confidence intervals, we were talking about, there's our two endpoints. I'm going to just use some nice numbers like 0.3 and 0.5. That means that my middle there would be p hat, which would be, in this case, 0.4, because 0.4 is halfway between 0.3 and 0.5. And so the margin of error would just be 0.1, right? Because this number would be p hat plus a margin of error, and this number would be p hat minus the margin of error. So I've also got 0.1. But that means that my entire width is 0.1 plus 0.1, so 0.2. So we are going to be given a margin of error. We are going to need to multiply it by 2 so that we can have the width, and then the width is what needs to go into StatCrunch. So the way that the problem will give us that information is it will usually say that we want our estimate to be correct within some percent. So let's see. In this example, you want your estimate to be accurate within 5%. So that within means 5% above or 5% below. So our margin of error is 0.5 or 0.05, excuse me, but our width will be 0.1. So our width is not the margin of error. So width, we need to double that margin of error. So once I have the width in, that's going to leave an empty spot for sample size. That's what we're looking for. So once these three numbers are filled in, you can click compute, and StatCrunch will give you the sample size that you need. It will round it to the appropriate number. You don't have to worry about rounding, which is nice. And technically, you would always want to round up, even if you got 115.015, you would want to round that up to 116. I know that seems weird, but if you round down, then your margin of, or your width is going to be more than what you are saying you want it to be. All right, so let's take a look at our example. So we wish to estimate with 99% confidence the population proportion of motor vehicle fatalities that were caused by alcohol-impaired driving. You want your estimate to be accurate within 5% of the true population proportion. So we have our confidence level, and here we're told for part A there is no preliminary estimate available. So our confidence level can be 0.99. I'm just going to write target, but the target proportion, we're going to leave the default of 0.5, and then the width, so within 5%, so that means plus or minus 0.05, which means the width is double that, which would be 0.10. Okay. So if I come in, and again, they're not going to be blank when you open this window in StatCrunch. It's going to have some numbers in here, but you can just type over them. So I'm going to put 0.99 for my confidence level. Since I don't have any information, I'm going to use that 0.5, just saying 50-50. And then for the width, again, remember, this is twice the margin of error. So in this case, 0.10. Now, when I click compute, here's one interesting thing that happens. It's actually going to change the width slightly. But that's okay. You don't need to go back and redo this, because it's just going to, when you click compute, it's going to change it back so that your sample size is given here. But this is what we're looking for. So I'm going to say that N is 664. So we need at least 664 in the sample. Okay. So pretty much every single what sample size do you need question in Pearson and in the actual physical textbook as well, gives you a situation, asks you, what if you don't have an estimate, what if you do, and then compare. So same thing on the test. It's going to actually be separate questions, but you'll have one where I'll tell you don't have a preliminary estimate. So you'll need to figure out the sample size by using that 0.5. Then you'll have one where you do have an estimate, and you'll change your target proportion, but it's all very similar. So my confidence level, that's not going to change. I'm going to put in 0.99. My width isn't going to change. However, I do need to retype it, because when we calculate or compute this sample size, it's going to change this, and we need instead 0.10. If you leave it this, it will actually give you the wrong number for part B. So we don't want to change, or we don't want to leave that as whatever, even though that would definitely round to 0.1. Right, 0.099961563, but even that bit of a difference will make that number incorrect if we don't change it back to exactly 0.10. Now, though, our target is going to be this sample proportion that we found from a previous study, and so 0.31. So again, here's my lovely screen. I would not have needed to change the confidence level. That would actually still be 0.99 from when I did the previous one. I would want to change my target proportion. Again, like I said, make sure you change this width back to 0.1. And then we'll click compute. And once again, once we do that, there's our sample size. Notice the width changes again, but it's not exactly the same. When I did this and I left the number that was in there from part A for the width, I actually got 569 instead of 568. And you all know as well as I do that Pearson can be picky sometimes. So just go ahead and change that. That way you don't have to try and figure out why Pearson is saying that your answer is wrong when you feel very confident about your process. So if we have this information, then we need at least 568, in this case, I guess, information about motor vehicle fatalities in the sample. So our comparison, anytime we have some information to work on, so instead of having just to use the 0.5, it's 50-50. If we have information, then that's going to lower our sample size. So having an estimate for p hat from a previous study will lower the minimum, sorry about that, there we go, minimum required sample size. And I believe I also have another video where I am using StatCrunch that you can watch me do 2 more problems very similar to this one, where we have our information, what if we don't have an estimate, what if we do, and then compare. So you can watch me click through in StatCrunch on that video if you need to see that happening without it just being me writing on paper from where I printed it out. Okay, have a great day. Let me know if you have any questions.